I want to do one last example of calculating a derivative, and then rather than give you an IXL, I'm going to give you a little bit of a worksheet where you're going to be doing this for, I don't know, 4 or 5 different problems. I haven't figured out how many yet. So this last problem that we're going to do is going to be finding the derivative of x cubed. All right, so this time f of x is equal to x cubed. And this is going to be a little bit more complicated because we're going to have to multiply out a little bit more. But I want you to look at this example because I think I'm going to make you do the derivative of x to the 4th power. All right, and so you're just going to be starting with this process and then building on from it. All right, so once again, we start off with the definition that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so that is equal to the limit as h approaches 0. So our function is cubing the input value. So over here we have x plus h cubed minus x cubed all over h. So let's take some space over here on the side and we'll calculate what x plus h cubed is equal to. So I'll start out by calculating x plus h squared, which is 2 copies of x plus h. And so x times x is x squared. X times h is xh. H times x, I'm going to write that as xh again. And h times h is h squared. And combining our like terms, we've got x squared plus 2xh plus h squared. And that was x plus h squared. All right, so to calculate x plus h cubed, that's just going to be x plus h squared times x plus h. And we just calculated x plus h squared. So that's x squared plus 2xh plus h squared times x plus h. And once again, we're just going to multiply all 3 of these by all 2 of these. So x squared times x is x cubed. X squared times h is x squared h. 2xh times x is 2x squared h. We've got 2 x's and 1 h. 2xh times h is 2xh squared. H squared times x is xh squared. And finally, h squared times h is h cubed. So combining all of those like terms together, x cubed, we've got an x squared h, and then we've got 2x squared h. So that's a total of 3x squared h. We've got 2xh squared and one more xh squared. So that's plus 3xh squared. And finally, we've got an h cubed. So that's what x plus h cubed is. So if I ask you to do x to the 4th power, you're just going to take this and multiply it by an extra x plus h. So there are going to be a bunch of different terms. There are going to be a total of 8 terms. You're going to be multiplying 4 terms of this times x plus h. But you just need to be careful keeping track of your terms, and you should be able to manage it without too much trouble. So x plus h cubed is equal to this. Oops, sorry, limit as h approaches 0 of x cubed minus 3x squared h minus 3xh squared plus h cubed, and then I need to subtract the x cubed from that, all over h. And it looks like a whole lot, but the x squared and the x squared are going to cancel out. The limit as h approaches 0 of 3x squared h, I don't know if I said minus or if I said plus in here, but these were all plus 3xh squared plus h cubed over h. So now that I've canceled out these two terms, every one of the remaining terms has got a factor of h in it. So I can just cancel out one term of h in all of those. So 3x squared h, when I take out a power of h, that leaves me with 3x squared. 3xh squared, I take out a power of h, that leaves me with 3xh. And h cubed, I take out a power of h, that leaves me with h squared. And again, this looks a little bit complicated, but as h approaches 0, this term is approaching 0 and this term is approaching 0. So the only term that's left is a term of 3x squared. All right, so therefore the derivative of x cubed is 3x squared. And when you look at the case of taking the derivative of x plus h to the fourth power, you might want to look at the pattern that's been set up. So the derivative of x squared was 2x. The derivative of x cubed is 3x squared. You might want to make a prediction of what you think the derivative of x to the fourth power will be. And if that prediction turns out to be true, then we've got the basis of a conjecture for how to find the derivatives of powers. And that's going to be called the power rule, which will make our lives much, much easier because we won't even need to do this level of algebra once we understand what the power rule is.